recording. Great. So here we are in math. Oops. 114. You guys are my section 6. So you should all have your practice test or remember what it was, right? Because I'll just steal that. Hello? Aren't I sharing my screen? There we go. I like the iPad because it makes it even bigger, I think, on there, minimally. Okay, so we're just gonna work through these. As you probably noticed when you're going through them, right, we start with the heavy hitters, and then we move to kind of the short answer, let's call them, right? It's because I want you to focus on these big questions, and then we can work through these short answers if we have time, or if we run out of time, then don't worry about it. All right, I'll post the solutions later today. Okay, so let's see here. Today we're making our practice test number 1, solutions. So what I'm going to do is I'm just going to steal each of these questions as we go. There's a typo, right? Who knew one little negative could throw us off so much in question 2? But we'll talk about that when we get there. It's possible to do it with the question like it was, but easier if you have the negative 125. Okay, so the first thing we need to deal with is something like this, right? So I give you some profit function P, right? And then we have conditions on that, right? So restrictions or constraints that we need to observe, okay? This one is pretty involved, right? Multiple steps. So what we do is first we have to draw all these constraints on the same graph, right? And so there's steps to drawing these lines, right? And then we find all the points of intersection, which could mean solving for the points of intersection sometimes, right? And then once we have our points of intersection, then we can evaluate the profit function and figure out what our maximized profit is going to be, right? So lots of steps. Okay. But if we break it down, it won't be that bad. So step 1, right, is to draw all constraints on the graph provided. Right, so what's nice is if you're looking at this one versus practice problems in the textbook, right? The practice problems don't give you the graph, so you have to make up your axes, which can be tricky, right? But on the test, I'll give you something like this, right? So it's kind of easier to start off with. Okay? So what do we want to do? We have, the echo is really annoying, but anyways. We have 2 big lines that we need to deal with, right? But then I've also thrown in a line at y equals 6, right? Saying that y can only be up to 6. Y is less than or equal to 6. Okay? So we'll start and say that, okay, equation 1, just writing them out, was 2x plus y. I'm going to ditch the inequalities and say that it's equal to 16, right? Because the inequalities just tell us which region to look at, right? But if we know that it's 2x plus y is less than 16, then it's everything below that line, right? So then we're kind of done with it. So I like to write it out as 2x plus y equals 16, right? Just because it's easier to look at, easier to think about. Okay. And equation 2, I'll just jot it down here, is 2x plus 3y is 24. After. Okay. So now, well, and we can say that equation 3 is just y equals 6. Okay. So we haven't done anything, but now I'm going to solve 1 and 2 for y, right? Putting it into y equals mx plus b form. So equation 1 is going to become y equals 16 minus 2x. That one's fine, right? Y is just on its own, so we can just move the 2x over, and then we have y equals mx plus b. Right? How about equation 2? Equation 2, we have the 3y, so we can say that 3y is 24 minus 2x. Oops. So y must be 24 minus 2x all divided by 3. Okay. So y, we can't just cancel willy-nilly, right? We can break up these terms and say that that's the same as 24 over 3 minus 2 over 3 times x. 24 over 3, we can simplify. Y equals 8 minus 2 over 3, we can't simplify. 2 over 3x. If you wanted to leave it as 24 minus 2x all over 3, that's fine, right? But we don't really like to look at stuff like that, right? So we like mx plus b. Okay. We have to draw these lines, right? So to draw lines, we need to find 2 points on each line, connect those points, and extend it, right? So to draw these lines, we need to find 2 points on each line. And you don't have to write out all this text, but I do want to see all your work, right? So if you're finding 2 points, you have to show me how you found them. So something like this. So line 1, I've got x, and I like to write out y equals 16 minus 2x. And then I'm going to pick 2 values of x, any 2 values, and solve for y. One thing to keep in mind is my graph only goes between x's 0 and 14. So I'm not going to pick any x that's outside that range, right? Because I want to be able to say, oh, if x is 2, for example, then y is this, right? And so I want to pick values of x that are in that range, but any of them are fair game. Our favorite, x equals 0, right? That one's good. So then we have y is 16. Another value of x, we can do, I don't know. We could look ahead and say, okay, well, if I let x be 8, right? But let's not, we won't do that. You can, but it eliminates a step later, so that's why you should do it. But not everyone sees that far in advance. So I'm not going to do it. If you do it, then you've eliminated a step later on, which is nice. Okay. Let's say x is 6. Okay. And I'm picking even values because my points are 2, 4, 6, 8, 10, 12, right? So if I picked 5, for example, then I would have to find the middle of 4 and 6, which is fine, right? But it's just nice to have these cutoff points to work with. So 6, so then we get 16 minus 2 times 6, 16 minus 12. Yeah. So in terms of our points, we've got a point at 0, 16, and a point at 6 and 4. Okay. All right. So I'm going to actually steal this. You have just the one in front of you, so you can just fill it in as we go. But for me, I'll just kind of keep cutting and pasting this until it's all done. Okay. So I've got a point at 0, 16. So x is 0, y is 16. And a point at 6, 4. So 6, 4. This is where we just take any straight edge, right? On the test, you can gently fold up your page and use that as your straight edge. Right? Anything, you don't have to be bringing a ruler or anything. And here we go. Did it do it? It's not drawing. Hey, come on. It drew it. Okay, cool. So now this is line 1, right? Y equals 16 minus 2x. It's going to be helpful to make a note of what line that is, right? Just so we don't have to decipher and work backwards later. Great. So we've drawn our first line. Do the same thing for the second line. So drawing line 2. Again, we need 2 points. So x and y equals 8 minus 2 over 3x. Again, we like x is 0. X is 0, y is 8. And then I'm going to pick a value of x that's divisible by 3 just because that makes my life easier. Right? You can pick any value, but I'm going to let x be, sure, let's let it be 6 again. It's one method. Picking the same x values, it's fine. So then y must be 8 minus 2 over 3 times 6. 6 divided by 3 is 2 times 2, so 8 minus 4 is 4. So on this line, we have 0, 8, and 6, 4. So again, I'll just steal this, keep working on it down here, just to show the steps too. What the? Huh. That is a pickle. Okay. Maybe I won't. Copy.
Paste image maybe you would do.
Yeah, maybe. Nice. Whew. You saved the day. What a relief. Oh, and now I made it too big. Anyways. Got carried away. So I'm going to use a slightly different color just to emphasize that this is the new one. But 0, 8, right? We have 0, 8 here. You don't have to, it's just so you can see it. And then 6 and 4. So now it's 6 and same 4. Man, I did it without even realizing. I should have used a different value. You know what? Just to illustrate, I'm not going to use this point, even though that would be good. That would be convenient, right? Because we've accidentally found the point of intersection. Just to show you that that's not always going to happen. Okay, I'm going to say, okay, instead of this guy, I'm going to pick a new value. Let's say x is 12. Right, then I have 8 minus 2 over 3 times 12. So 8 minus 12 divided by 3 is 4, times 2 is 8, so 0. So now I can go back here and say when x is 12, y is 0. All right, 12, 0. Okay. Try to draw this line again. So this is line 2. Y equals 8 minus 2 over 3x. And we have a line at y equals 6, right? Y equals 6 is just a straight line. Okay. So y equals 6, we'll just jot that in here. Wonder if I can, we'll see if this is straight or what. Equation 3 is y equals 6. Okay. So, phew. Step 2, right? We started with step 1 was, step 1 was draw all these restrictions on the same graph, right? Step 2 is identify and find some we know already, right? All points of intersection. Points of intersection. Because what we've found, right, is our, what we call our feasible set, which is going to be all the XY combinations that satisfy the restrictions. And so basically what you're going to think is, we could say, okay, well, y has to be less than 60 minus 2x, putting it down here, right? Or what it's always going to be like is moving from 0, 0, you're going to move out until you hit a line. Right? And that's going to be your feasible set, right? And then everything has to be below it. So our feasible set here is going to be all this area here. So all those XY combinations satisfy the restrictions that were stated initially, right? But as a fact, the profit function is maximized at one of the points of intersection. Okay. So let's see if I can cut this again. Copy. I'm just putting it down here. Paste image. Don't make it too big now, Emily. Oh, whatever. We're working down here anyways. Right. So our intersections here, I'm gonna label it A. I don't want to do numbers just because we have so many numbers on there already, right? So I'll do letters A, B, C, D, and E. Those are all my points of intersection. Okay. So making a list here, I have A, B, C, D, and E. Some of these we know, right? And so we're just going to jot down what they are. And some of them we'll just say, okay, we need to solve this, and it's the intersection of 1 and 2, for example. So A is always 0, 0. If you use the same naming convention as I do, I like to start at 0, 0 and then work my way clockwise around, but it doesn't matter. B, we know is at 0, 6, right? X is 0, Y is 6. C is the intersection of line 2 and line 3. Right? So we have to solve for that. So it's the intersection of line 2 and line 3. And that's when it's nice that we've already labeled these, right? Because then we can say, oh, I need this line and this line. Okay, 2 and 3. Right? D is the intersection of 1 and 2. Intersection of 1 and 2. And E is the intersection of 1 and the x-axis. The x-axis is always y equals 0. Right? So it's the intersection of 1 and y equals 0. The x-axis. The y-axis is where x equals 0. Okay. So we already accidentally solved for E. Right? We said, oh, let's use 8. Right? Oh, it's y equals 0. Oops. Right? But then we said something else. We used 6 instead. So we still have to solve for these. So solve for C. Right, so now I'm just gonna work through these kind of methodically. And so solving for C, the intersection of line 2 was y equals 8 minus 2 over 3x. And line 3 was y equals 6. Right. Substitution, right? We solve for one variable in one of the equations. Let's say y equals 6, right? We already know it. Substitute it into the other one. Right. So then we can say that 6 equals y, which also equals 8 minus 2 over 3x. If you don't want to have this kind of gateway, 6 equals y, y equals 8 minus 2 over 3x, that's fine. Right? We could just write 6 is 8 minus 2 over 3x. Because by definition, the point where they intersect, that is where the two lines are equal. Right? Okay, so now we can solve for x here. We can subtract 8 from both sides. However you want to solve for it is fine. Right, so 6 minus 8, negative 2 is negative 2 over 3x. To move the 3 over, I have to multiply by 3. So negative 2 times 3. And to get the negative 2 over, I have to divide by negative 2. It's x. These guys are going to cancel, so x is 3. Okay. Solving for y, right?
6.
Yeah.
So
We already know that y has to be 6. Right. So C is at 3, 6. And you can double check. Now, I don't want you to rely on your drawing, right? Because I don't know if you can see here, but my 8 dash is actually here. We know it's crossing at 8, but I just drew it kind of wonky, right? And so you can't rely on your graph to figure out where these points are. We have to solve it mathematically. Right? So that's something to keep in mind. So C, we're saying, is at 3, 6. Does that look reasonable? Oh, yeah. Right. So you can use it to check, but not to find the points of intersection. Okay. How about if we have to solve for D, the intersection of 1 and 2? Solve for D. Line 1 was y equals, what, 16 minus 2x? And line 2 was y equals 8 minus 2 over 3x. What's nice is that, again, we have these already solved for y. So we can set them equal to each other and say that 16 minus 2x must be equal to 8 minus 2 over 3x at the point of intersection. Collecting like terms, right, we can get the 16 minus 8 on the left-hand side and negative 2 over 3x plus 2x on the right-hand side. Now, if you wanted to do 2 minus 2 over 3 on your calculator, that's fine, right? But I'll just show you how to do it by, because we have to have common denominators on the right-hand side to be able to add up those fractions, right? So 16 minus 8, we'll just call it 8, is negative 2 over 3x plus 2 as a fraction of 3 is the same as 6 over 3, right? I can replace the 2 with 6 over 3 because I have to have that common over 3, common denominator. X. So pulling out a common x and rewriting it because I like to have 6 minus 2, right? So then I have 6 over 3 minus 2 over 3, just changing the order. Oh, because I'm replacing this 2, because I need to write it in terms of something over 3. And because we know that 6 divided by 3 is 2, then I can replace it. If it wasn't that simple, right, then you would cross multiply, right, and say that, okay, I need 2 times 3 over 3 is the same as 6 over 3. Can do that too. Because 3 over 3 is just 1 to force it to be over 3. Okay. So from here, now that we have these like terms in the denominator, now we can just say 6 minus 2 over 3. So now we have x times 4 over 3. And we've got 8 on the left-hand side, just holding steady. Okay. But now I've got 8 times 3 divided by 4, right? Multiplying by 3, dividing by 4, or basically flipping the fraction and moving it to the other side. So x must be 8 times 3 divided by 4. Which we found accidentally, but I do need you to show your work. Show that you can find these points of intersection. So now, use x equals 6 to solve for y. You can use either one of these equations, right? But I'm going to use the easiest one, y equals 16 minus 2x. 16 minus 2 times 6. 16 minus 12. So D is at x equals 6, y equals 4. How about point E? E is the intersection of line 1 and y equals 0. Solve for E. Line 1 is y equals 16 minus 2x, and y equals 0. This one's breezy after the last one. Right? So we have just 0 equals 16 minus 2x. Moving the 2x over to the left-hand side, I get 2x is 16, so x must be 16 divided by 2, so x must be 8. And we already know that y must be 0. So E is at x is 8, y is 0. So just stealing our graph, I'll come back down there. Stealing this. On your graph, right, you would make a note and say, okay, well, I know A is 0, 0. B is 0, 6. C we decided was what, 3, 6. D we just found was 6, 4. And E we just found was 8, 0. All right, so you would put all your points of intersection on there. Woo. Home stretch, step 3. evaluate the profit function at each point of intersection. Right, so I've got making a table here. I've got the intersection A, B, C, D, and E. Writing them out, I've got 0, 0, 0, 6. I just set it 3, 6. D was 6, 4, and E was 8, 0, right? So I'm building up a table here of my intersections and my profit P. Notice that this is the first time that we're even looking at this profit function, right, since we started. So I don't want you to throw it in too early, right? P is 2x plus 5y. So now we evaluate P at each of these points. So when x is 0, y is 0, we get a P of 0. When x is 0 and y is 6, we get a P of 30. Right? And when x is 3, I'll just write it out because this one's not that obvious. We get 6 plus 30, 36. That's pretty good. How about 2 times 6 plus 5 times 4? I get 12 plus 20, 32. And then I have 2 times 8 plus 5 times 0, 16. Nice. The highest one on here is 36, right? So this is the maximum. So we write the profit, or just capital P if you want. The profit is maximized at 3, 6, right? Or if you want to say x equal to 3, y equals 6, that's fine too. For a profit of 36. Cool. It's a lot of work, right? It's going to be a lot of marks. So you want to make sure that you get those down and kind of solid. Any questions about that one? Okay. Lots of chitter chatter, but no questions for me. Let them sort it out. It is. All right, we're ready for question 2. This is the one where I had a typo, right? One little typo. You can solve it either way, but it's easier if it has a negative. So question 2, oh, I'll steal it from here actually, just so you can see where it's from. There it is. Maximize this function. So to maximize a function like this, right, we don't have any constraints, I don't give you a graph, we can still maximize this by taking the derivative, set the derivative equal to 0, solve for x, and then substitute that value of x back into the function, and then that's your maximized function, right? So step 1, find the derivative of x, or of f of x. Find the derivative of f of x. F prime of x is the derivative of f of x. Do you remember what we did? We bumped it from the right, kind of decreased the powers, right? So we get negative 125 times 2x, technically to the power of 2 minus 1. You don't have to write that if you're comfortable with just leaving it as x, plus 300 technically times 1 times x to the power of 1 minus 1. Minus 0. The derivative of a constant is just 0. Or if you went straight to this, negative 125 times 2 is 250x plus 300. That's fine too. So now we have the derivative is negative 250x plus 300. Step 2, set f prime of x equal to 0 and solve for x. So we can say that the derivative of f of x is equal to 0, but it's also equal to negative 250x plus 300. I can move either of these terms over to the left-hand side, trying to solve for x. I'm going to move the negative 250x, constantly trying to avoid negatives if I can, right? I guess it's nice to have an agenda. So 250x must be 300. So the x that makes the derivative 0 must be 300 divided by 250, or x of 1.2. All right. I'll just make a note here. So f of x is maximized at x equal to 1.2. That's what we found, right? But I want to maximize the actual function. So I want to evaluate f of x at x equal to 1.2. Right? So step 3. Solve f of 1.2, right? Which is f of x at x equal to 1.2, right? Using function notation. So f at 1.2, being careful that you don't use the derivative anymore, right? You have to use the actual function. Okay. So f of 1.2, or I'll write down in general, f of x, just so we remember it. F of x was negative 125x squared plus 300x minus 2. So negative 125x squared plus 300x minus 2. So f at 1.2 is negative 125 times 1.2 squared plus 300 times 1.2 minus 2. So we have to square the 1.2 first. So 1.2 squared, negative 125 times 1.44 plus, I can simplify 300 times 1.2, 360 minus 2. Doing more than one thing at each step, but that's okay. Kind of used to it now. And then negative 125 times 1.44 minus 180 is what I have. Yeah. Minus 180 plus 360 minus 2. Yeah, 178. So f of x is maximized at x equal to 1.2 with a max of 178. Mm-hmm. If you want to practice these, you can actually look at the suggested exercises for, I think 3.4, oops. For 3.4, on my book, it's on page 87. Okay. It looks a little bit different than what we're used to, but I'll just show you why they're the same. And I said we didn't do this section, but we sort of did. So something like, we're given that the total revenue of x is 4x minus x squared, and the total cost is 2x. Those look familiar, right? Not in this context, but they're familiar. So we know that the profit function, we can build a profit function out of this if we know the total revenue is given by 4x minus x squared, and the total costs, it's just thrown in for extra practice, attached to number 2 still. So we know that the profit, right, is from our formula sheet, the total revenue minus the total cost, right? And here we're given the total revenue and the total cost. So we can set this up as 4x minus x squared minus 2x. You can say 4x minus x squared minus 2x, right? Getting rid of the brackets, they're not doing anything. 4x minus 2x makes 2x minus x squared. So now we can maximize the profit of x is 2x minus x squared. Right? So you can use those problems to make more profit functions that you have to maximize if you want to. If you want more practice problems. If you don't, then ignore that. No, no, it'll be in this shape. Maximize f of x, or I might say profit of x. It doesn't matter. And then you have to know the steps. Okay. Any questions about that one? Okay. Moving on to question 3 then. Ruth. So this one's a little bit hard to wrap our head around, right? Because we have this, okay, so first of all, she's making milk carton openers. But anyways, so Ruth is making these milk carton openers, and we're given a bunch of information about her business, right? And so the first thing that we have to do is find Ruth's profit function. Right? And that's going to be hard to do because it's hard to figure out what we're given, right? So what I would do, how I would approach this problem is you could start by listing everything that you've given or you've been given, right? Or I would start and write out the profit function. It's like, okay, part A, I have to find the profit function. So write out what you have, right, for the profit function in general, and then see what's missing, and then try to use the information that you've been given to fill in those pieces. Okay. So here's how I would probably do it. It doesn't matter how you do it. But the profit, part A, profit of X, we know is the total revenue minus the total cost. Okay. Total revenue, we can replace it with P times X. Right, just placeholders for now. Minus the total cost is the variable cost plus the fixed cost. Okay. So from here, right, we can read back and say, okay, well, each opener costs $2 in materials, right? So for each opener that we produce, we have a variable cost of $2 per unit, right? But it also takes time to make a carton opener, right? So it takes 20 minutes to make one, and she charges $30 an hour. And this is a pretty common setup, right? That we have, it would take me half an hour, I charge $50 an hour, right? That kind of thing. Or, that's gonna take me 5 hours, I charge $100 an hour, right? And that just gives you an idea of how much it's gonna cost per unit, right, to produce this thing. Okay. So we actually have 2 things for the variable cost. So the variable cost is the $2 in materials plus 20 minutes in labor, or minutes of labor. In labor would be something else. So then we have $2 in materials, 20 minutes of labor at $30 per hour. So we know it costs she charges $30 an hour, but she only spends 20 minutes per carton opener. And so 20 minutes, we have to convert 20 minutes to what's the fraction of an hour? So 20 minutes, there's 60 minutes in an hour. So 20 minutes is the same as a third of an hour. Okay. If you wanted to justify that just in words, because I think we all know that 20 minutes is a third of an hour, right? But we don't necessarily know how to show that mathematically, that's fine. If you just say 20 minutes is a third of an hour, right? Then that's fine. So each unit costs $30 times a third. So $10 in labor. Leaving our variable cost must be 2 times X, right? $2 in materials per unit. So we tack on that X plus, again, 10 times X, $10 in labor times however many we're producing. So we have a variable cost of 12X. Right? Or I should just say 12 is C, right? The total per unit cost is 12. Okay. Moving on to our fixed costs, right? Reading our little blurb here. So we've dealt with the $2 in materials and 20 minutes to make it at $30 per hour. We've dealt with that. Right? Ruth's advertising costs are $30 per month, and rent for her place is $3,000 per month, presumably. Okay. So our fixed costs are going to be the $30 in advertising plus $3,000 in rent. So it's actually pretty rare that our fixed costs and our variable costs only come from one source, right? We have materials, we have labor, we have things like advertising costs and rent, right? So we need to divvy those up into fixed cost, variable costs. Okay. So our fixed costs then are $3,030. Now we can say, okay, well, remember our profit function? Profit of X, we kind of left it hanging because we said, well, we don't know our variable costs and our fixed costs, we'll come back to it. Okay. So now I'm gonna just jot that down. So we said the profit, picking up where we left off, is PX times variable cost plus, or minus the variable cost plus the fixed cost. We don't know P. P, remember, is the amount that we sell the item for. I don't see it anywhere in the blurb, right? And so even though I give it to you later on in part C, right, you don't know what it is. So that's fine, we just leave it as P. So we have PX minus the variable cost was 12X plus 3030. So expanding out the brackets, we get PX minus 12X minus 3030. Collecting our like terms of X, right? I like to put it X times P minus 12 minus 3030. And that's as far as we can take it. but that's your profit function for part A. Just to emphasize that that's the end. So Ruth's profit function is profit of X is X times P minus 12 minus 30, 30. Well, if you just end it here, right, that's fine. Just kind of here. Da, 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 da. You don't have to say what it is, right? I just want to show you that we could summarize it, right? Part B. What is Ruth's shutdown point? This means we have to remember what the shutdown point is. The shutdown point is when the price that we can charge per item is actually less than the cost to produce each item. Right? So just as a fact, the shutdown point, oops, the shutdown point is when P is less than C, right? Or if we wanted to write when P minus C is less than 0, in our case, right? In this case, when P minus 12 is less than 0, or P is less than 12, right? When the price that we can charge per item is less than $12, we just established that it costs $12 in materials and labor to produce this thing. We need to shut it down. Okay? So P less than 12 is the shutdown point. Bless you. As far as work goes, just showing that would be fine. Do you see my highlight there? I highlighted. Maybe I'll do a darker highlight, red. So that's all you would need to show for work. Right. The other stuff, I'm just saying, hey, here's what it is, right? Okay. How about part C? Part C, if she sells the milk carton openers for $20 each, so now we have this P, yeah. No, because there's gonna be, those fixed costs are there even if you don't produce anything. So even if you're making a negative profit, you're still eating into those fixed costs. So for some amount of time, right, as long as you're selling the item for more than it costs to produce it, you're still eating into those fixed costs. Right? And so it's kind of like this. So as soon as you can sell it for more than it costs to make, then you start production, and then you make a negative profit until you've covered the fixed costs, and then you make a positive profit, right? So there's that region that we don't like, right? Negative profit, but we still sell it because it's eating into that fixed profit. but yeah, or fixed costs, sorry. Cool. So now we're told, okay, she's going to sell these for $20 each. So P is going to be 20. What's her break-even output, right? How many does she need to sell to break even, moving from that negative profit to a positive profit? So part C, let P equal 20. What is the break-even output? Just summarizing. Right, that's where the profit goes from 0 to positive, or negative to positive, right? So we set the profit equal to 0. Okay. So remember our profit function. Profit of X in general, we said was X times P minus 12 minus 30. And now we're told let P be 20. So we have X is 20 minus 12 minus 30. 20 minus 12 is 8, so we have 8x minus 30. So when P is 20, this is our new profit function, 8x minus 30. Let profit of X be 0 and solve for X. We want to find what value of X is that turning point for between negative and positive profit. So we say that, okay, profit of X, I'm going to force it to be 0, which is 8x minus 30. I'll move the 30 over to the left-hand side, so I get 30 is 8x, so x must be 30 divided by 8, divided by 8. X must be 378.75. Right? We can't sell 0.75 of a carton opener, right? So we would say, or 379 units. $378, we'd still be making a negative profit, right? 379, now we're making a positive profit. So that was the question for that, right? So it's just asking for the break-even output. So it's just asking solve for X. We could go on and ask, so then, well, part D. So if she wants to make $5,000 in profit, not 0 anymore, right? So we want some fixed profit. Then how many does she need to sell? Same idea as we just did, right? Just a better profit to deal with. Okay, so we're still selling them at $20 each. Okay. So part D, right? Let profit of X be 5,000. Solve for X. P equals 20 still. So again, we say that the profit of X, now I'm going to force it to be 5,000, and following the exact same format as before is 8x minus 30, right? Because this is 8x minus 30 is our profit function when P is 20, right? Solving for x, again, we can move the 30/30 over to the left-hand side. So now we have 80/30 is 8x. So x must be 80/30 divided by 8. 80/30 divided by 8 is 1003.75. Or 1004 units. On the test, there's a lot going on, right? And so if you left it at x equals 1003.75, that's fine, right? It's just if you want to show off, you tell me, okay, well then I have to sell 1004 units. But technically the break-even output is 1003.75. So you're not wrong. Any questions about that one? Hardest part, right, is setting up your profit function. And then the rest kind of flows. Okay. We can do 4 if you, no, we can't. 5. We can do 4 if we want to, but oops. So number 4 is not on the test, but good for practice for a question like number 2, right? We can still do it. We just didn't talk about it, so it's not on the test like that. Question 2 is on the test. Okay. So now we're getting into what I'm going to call the short answer questions. I'll just make a little note here. Short answer from now on. I put them at the end, like I said, because I wanted to definitely have time to go through those big questions. And then the short answers, they're kind of wild cards, right? Even though, right, 6, 7, 8, 9, 10, 11, those could be anything, right? They're not necessarily exactly the same format. Yeah.
About how many questions will be on the test?
Just like this. Yeah. Yeah. Okay. Yeah, this, I do the practice test and it'll be exactly what you can expect to see. Okay. So, supply and demand functions. Who knows what those things? We want to find the equilibrium quantity and price, right? So equilibrium is the point of intersection. What again? We just did, right? But a little bit easier because they're all in terms of Q. Q equals, Q equals, Q equals, Q equals. So a little bit easier. So if it felt like things got easier, the further into the practice test you got, then that is the case. Okay. So part A, we have the supply curve is Q equals 16P, and the demand curve is Q equals 12 minus 2P. Equilibrium, just as a note, is when the supply equals the demand curve. So we can call this equation 1 and this equation 2. So we want to set equation 1 equal to equation 2. they're both in terms of Q, right? And that's why we can just set them equal to each other. Otherwise, we'd have to solve for one of the variables, substitute it back in, right? But we can just say that 16p equals Q, but Q also equals 12 minus 2p. And like I said, I like to have the middleman of Q in there just to emphasize that this equals this equals this, right? Or we can just skip to 16p equals 12 minus 2p if you want. Solving for p, we can move the 2p over to the left-hand side. So now we have 18p, right? We have to add 2p to both sides. It's 12. So p must be 12 over 18. P, remember, is a price. So we only need 2 decimal places. So, or 0.67. Could have kept it. You can leave it as a fraction, yeah. Yeah, you can leave it as a fraction. I don't like dealing with fractions, but yeah, it's more accurate. So then once we have P, right, now we can solve for Q. Solve for Q, we have 2 choices for Q equals 16p, sounds good. So Q equals 16p, or if you wanted to use the other one, that's fine too. So Q is 16 times 0.67. So we have a quantity of 10.72. So equilibrium is when the price is 0.67 and Q is 10.72. How about B? We have a supply curve of 16p minus 8 and a demand curve. Oh, sorry, Q equals. Squeeze that in there. And then Q equals 16 minus 2p. Setting these two equal to each other, right? I have 16p minus 8 is Q, which is 16 minus 2p. And I'll move the 2p over to the left-hand side and the 8 over to the right-hand side. So then I get 16p plus 2p is 16 plus 8. So I have 18p is what, 24? P is 24 divided by 18. Price again is a price, so we have 1.33 repeating or $1.33. So Q, again, we have 2 equations we can choose from, I should say. So I'll use the second one, doesn't matter. 16 minus 2p. Q is 16 minus 2 times 1.33. 2 times 1.33. 16 minus that. 13.34. Yeah, it doesn't matter. You should get the same answer though. Okay. So equilibrium is when P is 1.33 and Q is 13.34. Any questions about that one? No? All right. A Dyson vacuum cleaner has a list price of $430 and trade discounts of 35% and 20%. What's the net price of the vacuum? It's too easy. Let's just list what we're given. So we're given the list price is $430. Discount 1 was 0.35 and discount 2 was 0.20. And we want to find N. We need a formula that has all these things or is going to let us get to all these things. But we already know from our formula sheet that N is L times 1 minus D1 times 1 minus D2. Let's fly up here. So we can plug in our values and solve. So 430 times 1 minus 0.35 times 1 minus 0.20 is 430 times 0.65, right? Times 0.80. 430 times 0.6, oops. 430 times 0.65 times 0.8. I get 223.60. Nice. On to the next one. If a jacket's sale price is $50 and the markdown is 40%, what was the original price? So we're told that the reduced selling price, S subscript R, is 50. And we're told that the rate of the markdown is 0.4, right? Find S. From our formula sheet, we know that the reduced selling price is S times 1 minus the rate of the markdown. We want to find S. So we know that the reduced selling price is 50. That's the formula, right? I'm winging it up here. Yeah. So 50 times the reduced, or the original selling price, which we're trying to solve for, times 1 minus 0.40. So we have 50 as S times, or I'm going to write 0.6S. So S must be 50 divided by 0.60. 50 divided by 0.6, 83, or 83.33. Nice. Any questions about that one? Snag another one. Future Shop, remember those guys? Ah. Future Shop decides it wants a ROMU of 20%, so the rate of markup of 20% on the new iPhone 5. Aren't you jelly? What is the GPM in percent, right? What's the gross profit margin? Okay. So we have multiple formulas for the gross profit margin, but the one we're going to use is the one that involves the ROMU, right? Just because that's what we're given, right? So we want to solve for the gross profit margin, which is, and I can't remember off the top of my head what it is. It's the ROMU 1 plus, thank you, over 1 plus the ROMU. Thank you. Okay. The rate of the markup was 20%, so we have 0.20 over 1 plus 0.20. So we have 0.2 over 1.20. So 0.2 divided by 1.2 is 0.166, repeating. Or as a percentage, so the gross profit margin, and here's where I'm going to get kind of picky, right? If I ask you for it as a percentage, then you have to give it as a percentage, right? So you can't just leave it. In general, you have to give me the answers as I'm asking for them. So the gross profit margin is 16.67%. I didn't specify how many decimal places, right? But let's just play it safe and say 16.67 or 16.7 if you want it. Okay. Any questions about that one? We're just ripping through these. Okay. Question 9. A Sony 50-inch TV sells for, is that inches? 1 apostrophe? A 50-foot TV. It's impressive, right? And it only sells for $1,000. With trade discounts, better get to Future Shop right away. So a Sony TV sells for $1,000 with trade discounts of 15 and 35%. What is the list price? This one's a little tricky, and we have to be a little bit flexible, right? Because, okay, the $1,000, is that how much we're selling it for? Or is that how much we pay for it after the trade discounts, right? But because it's asking for what's the list price, right? We can assume that the $1,000 is what we paid for it, right? After these deductions have been taken off, right? The trade discounts. And then we want to know what's the list price. So we're given that the net price is 1,000. Discount 1 is 0.15 and discount 2 is 0.35. Find L. Okay. On the test, I've tried my very darndest to not have something like this happen, right? Where it's not quite obvious what's what. Okay. But no, I've done a pretty good job. Okay. So we know our net price is our list price times 1 minus D1 times 1 minus D2 from our formula sheet. So we're told that the net price is 1,000. L is what we have to find, times 1 minus 0.15 times 1 minus 0.35. So we have 1,000 is a list price times 0.85 times 0.65. Okay. We can combine the 0.85 times 0.65 to one number, right? And then we can divide it over into the 1,000, or we can divide them over individually, it doesn't matter. Okay. But I'm gonna do 0.85 times 0.65. So we have 1,000 is L times 0.5525. Careful not to drop any decimal places. So L must be 1,000 divided by 0.5525. 1,000 divided by 0.5525. We have a list price of $1,809 and 0.954751, just so you can check, right? So L must be $1,809.95. A little bit more work, but nothing compared to the first few questions, right? Any questions about that one? Now we'll keep going. Question 10. A Sony 50-foot TV, again, sells for $1,000 with trade discounts of 15% and 35%. We just did that. What single trade discount would be equivalent to the 15% and 35%? Okay. You have a question like this on your Moodle quiz that's due tonight, right? What? You have until 11:59 p.m. to get it in. It's the average. You can check your answers while you're in the quiz. Okay. So even if we didn't know these things, right? We can solve, so even if we didn't know the list price, we can still find a rate that's equivalent to these two rates. Okay. And so if you're having troubles with that one, we can go through it together later. But for now, right? I'll just list the things that we have. So we have a list price of 1,000 again. D1 is 0.15 and D2 is 0.35. And we found that the net, or sorry, oops, I made a mistake. We said the net price was 1,000. Sorry, guys. And we found that the list price must be $1,809.95 from question 9. You can use stuff that you found earlier, right? If you're sure that it matches, that's fine. So we want to find, so find D equivalent to D1 and D2. So we have something like this. N is the list price times 1 minus D. So there's one D that brings the net price to 1,000 if the list price is $1,809.95 times 1 minus D. And that D is equivalent to those two discount rates. Lots of ways we could have solved this. Okay. So we have 1,000 divided by 1,809.95 is 1 minus D. So I have 1,000 divided by 1,809.95, 0.55250145 is 1 minus D. Adding D to one side, Moving the 0.55 over to the right-hand side, I get D is 1 minus 0.55250145. I get D of 0.44749855. So single discount of 44.75% is the same as a discount of 15 followed by 35. Okay, and I'm all out of time. I'll post the solutions to the very last one on Moodle. And if there aren't any questions, I'll see you on Wednesday for the testing. To this? Yeah. Yeah. It'll be, I post the notes, right? Yeah.
So for the to buy the list price in the test,
In this case, we had it already, right? What you could do is you could say that the net price is the list price times 1 minus D. Has to be the same as the list price times 1 minus D1 times 1 minus D2. So then you can cancel, cancel. So it doesn't actually matter what the net price and the list price is, because then you're saying that 1 minus D must be equal to 1 minus D1 times 1 minus. So you could solve it that way too. Yeah. So you have to be here at the beginning of class. I can give you half a mark. Okay. Let's see here. Let me just go back here.